In question 6, the diagram shows the curve with the equation y equals to 5x power half and the line with the equation y equals to 2x plus 2. We have to find the exact area of the shaded region which is bounded by the line and the curve. Now, to find the area of the shaded region, in the first step, we need the point of intersection of the line and the curve, so we can have our limits for finding the area. Now, to find the point of intersection, we'll equate the two equations. So this will be 5x power half is equals to 2x plus 2. To find the value of x, we can whole square both the sides. So when I whole square the left-hand side, 5 square will be 25 and x to the power half whole square will be x. Expanding the right-hand side, this will become 4x square plus 8x plus 4. Bringing the 25x on the right-hand side, we get 4x square plus 8x minus 25x plus 4 equals to 0. Simplifying, it will become 4x square plus 17x minus 17x. So this will become a minus 17x plus 4 equals to 0. Now, solving the quadratic equation by Milton breaking or using a calculator, we'll get 4x square minus 16x minus x plus 4 equals to 0. Taking 4x common, this will be x minus 4, and taking 1 common, this will be x minus 4 equals to 0. So we'll get 4x minus 1 and x minus 4 equals to 0. The two values of x will be x equals to 4 and x equals to positive 1 upon 4. So now we have the limits for x. So the lower limit is 1 upon 4 and the upper limit will be positive 4. To find the area of the shaded region, we need to find the area under the curve and then the area under the line and then subtract the two areas. So we'll write area will be is equals to integral of the equation of the curve 5x to the power half. The limits will be 4 and 1 upon 4 minus the area under the line. So the equation of the line is y equals to 2x plus 2. And the limits will be 4 and 1. What we can also do is we can combine the equation to write it as 5x to the power 1 upon 2 minus 2x plus 2, and then apply the limits and get a final answer for the area of the shaded region. So when I integrate 5x to the power 1 upon 2, I will get 5x to the power. So increasing 1 upon 2 by 1, that will become 3 upon 2 divided by 3 upon 2 minus integrating 2x, that will become a 2x square upon 2, and integrating 2, that will become a 2x. So simplifying this will become 10 upon 3. So the 2 will go in the numerator. This will become 10 upon 3 x to the power 3 upon 2 minus 2 and 2 will cancel. So this will be minus x squared and minus plus will become a minus. So this will be minus 2x. Now applying the limits, so the upper limit was 4 and the lower limit was 1 upon 4. Substituting 4 into the equation, we get 10 upon 3 into 4 to the power 3 upon 2 minus 4 squared minus 2 into 4. And then applying the lower limit, which we'll subtract from the upper limit, this will become 10 upon 3, 1 upon 4 to the power 3 upon 2 minus 1 upon 4 whole squared minus 2 into 1 upon 4. Now we can directly substitute this in the calculator as well. So 10 upon 3, 4 square root will be 2 and 2 cube is 8. So this will be multiplied by 8 minus 16 minus 8 minus 10 upon 3. The square root of 1 upon 4 will be 1 upon 2 and 1 upon 2 whole cube will become 1 upon 8 minus 1 upon 16 minus 1 upon 2. So this will be 80 upon 3 minus 24 minus this will become 10 upon 24 minus 1 upon 16 minus 1 upon 2. Opening up the brackets, we'll get 80 upon 3 minus 24 minus 10 upon 24 minus 1 upon 16 minus 1 upon 2. Substituting these values in the calculator, the final area will be 45 over 16, or we can write this in decimal as 2.8125.